Welcome to lecture number 79, and we got ideas if a DC machine is connected say either in shunt or series fashion, and if it is drawing some current running at some steady speed, then what all you have to do is you have to write down two equations. One is the back EMF equation. From the circuit point of view, it is V minus IARA, and another is the torque equation IF into IA, neglecting saturation. And then if you change some quantities in the circuit, for example, you might only change the armature voltage applied for a separately excited machine. So, machine will then operate under another steady state conditions. Then once again write down those two basic equations and take ratios, and you will get the new quantities. Okay. So, that was the basic thing we must know before we further proceed. Now, for any motor operation, three things are important. Motor, be it AC, DC motor, it does not matter. If it is these three things are that it's starting, then its speed control, how speed can be controlled, and another is called braking, electrical braking. That is, if you want to bring the machine to stop very quickly electrically, what you should do. These are the three things one must know about the motor. So, DC motor is also no exception to this. So, first we discuss about starting of DC motor, and suppose a shunt motor. Shunt or separately excited motor, shunt motor, let us take general shunt motor starting. And we know the starting phenomena, that is, if you have this armature and this is the field, they are connected in parallel, and then here you will give supply. Rated voltage. Now, we discussed about this problem starting from rest, that is, machine was stationary, but the order of the armature resistance is small. How small it is, we also discussed about that. And if you apply full rated voltage at the time of starting, there is no back EMF, therefore, current drawn by the armature will be very large. About field circuit, no problem. Field circuit V by RF is the current, steady state current. Therefore, here the problem is armature current may be many times larger, and if it is a large DC motor, inertia may be large, therefore, back EMF will slowly build up. Phi has built up, but N will increase slowly if its inertia is high. Then the level of that large starting current drawn by the armature will also persist for a longer time, and your machine may be damaged, particularly armature winding. And if armature winding is damaged, it is very difficult once again to repair, cost is a factor. Therefore, some protection is to be taken at the time of starting. Now, in today's context, to start such a machine, you can have a variable DC supply voltage. Suppose 220 volt is the machine rating. then you do not apply 220 volt across the armature of the machine. You have a variable DC supply voltage with a power electronics converter, slowly increase the applied voltage starting from 0, then there will be absolutely no problem. Applied voltage is small, current drawn will be small. As the machine picks up speed, go on increasing the voltage, and then finally set it at the rated voltage, no problem. That is not a very big issue perhaps in today's context, but nonetheless in earlier days and also in some places it is still used. At least one starter I will tell you about, that is called 3-point starter. 3-point starter, which is an electromechanical device to start a DC shunt motor. Okay. So, what is basic idea is this, that at the time of starting this voltage is rated. So, I am not talking about variable DC voltage that would have been nice, but rated voltage supply is available and I want to start the DC shunt motor. And I know armature resistance is small. So, at the time of starting speed is 0, V by R A, which may be many times larger than the rated current, that I want to avoid. So, one solution is obviously connect some external resistance in the armature circuit, connect R armature external with capital letters, this I will indicate R A in the armature. So, that the starting current, then earlier it was V rated by R A was the starting current. Now, it will be V rated by this small R A plus this R A external. This will be the starting current. Therefore, you can reduce the starting current substantially by incorporating a resistance in the armature circuit. And as the machine picks up speed, then you gradually cut out the armature resistance to 0, external this R A back to 0. So, that machine will operate at full rated voltage with inherent armature resistance in the circuit. That is the idea. Now, therefore, I have to connect R A and initially at the time of starting, and as motor picks up speed, gradually cut this resistance, this R A to 0, sort of variable resistance you connect. So, that is the idea, you connect an R A initially maximum, then gradually cut it back to 0. So, finally, it will be only small R A present in the armature circuit, and you can reduce the armature current drawn from the supply to whatever extent you want, you can do it. Mind you, the field current is V rated by R F, that is no problem, total field circuit resistance. But the only problem may be you cannot reduce it to any number you like, because the starting torque is proportional to product of field current and armature current. If you reduce this armature current to a very small value, then the electromagnetic torque developed by the machine will not be able to make it start if the motor has to start against a opposing load torque. That you must see, that okay, it is reduced. Maybe I will say that whatever is the rated current of the armature, I have a knowledge. Suppose the rated current of the armature is 30 ampere, I at least safely it can take 30 ampere. Armature resistance is suppose 0.5 ohm, and IA rated is equal to 30 ampere say or 20 ampere say, just for calculation sake. Then I will say I will, and suppose the supply rated voltage is 200 volt, 200 volt. Then I will say that I want to make the starting current IA starting is equal to this 200 volt divided by this 0.5 RA plus RA external, and I will restrict it to 20 ampere. Based on that, I will be able to calculate RA. So, rated current I will pass, so that the torque developed by the machine remains high, starting torque should be high. So, from that I can calculate RA. In fact, this 0.5 is so small, so RA has to be 10 ohm approximately. You connect and get this done. Now, therefore, the solution is connect an external resistance in the armature circuit, then parallel it with field, then give rated voltage. That is the idea. But the problem is not problem, okay, motor is running. Now, suppose the supply goes off because of some problem on the supply side, supply becomes 0, load shedding. Then what happens is this machine will come to a stop, both armature current and field current will become eventually 0 if supply is switched off, and machine will come to a stop. And suppose supply comes back, it comes to stop, but before you notice it, supply comes back to this circuit with this switch on. Then what will happen? Once again this RA external I have made it 0. So, once again the current flowing through the armature will be V rated by RA, and that is a dangerous thing. Therefore, if the motor is working in an industry, therefore, there must be always one man present there in such a situation, because you do not know, anything can happen, supply voltage may just go off. Then after noticing that, he will once again bring this RA back to its normal value immediately, because you do not know when supply will come back. So, that once again things can go. Even human intervention is necessary, and human may make mistake, he can forget and problems are there. So, there must be some automatic features, not just an RA you connect, which will not only allow you to start the motor keeping the armature current at a low value, but at the same time also protect the machine when the supply goes off. So, one starter which has been extensively used and also nowadays used by some old industries, you will find that. So, that thing I will discuss, at least one starter you must understand how people started DC motor. So, the circuit is like this. What happens is this 3-point starter in a black box, if I put it, this is 3-point starter, it is called. It is interesting, its functioning, 3-point starter. It will have 3 terminals. What is inside this, we will see that, but before that I am just trying to tell. One terminal is marked as A, another terminal is marked as L, another terminal is marked as F. That is how it will be there. Now, your DC machine will be like this. It has got armature terminals A1, A2, and suppose its field winding has got terminals F1, F2, and you would like to connect some resistance in the field circuit, which you will be able to control if you want to control speed, which I have not discussed yet, but generally an external resistance is connected in the field circuit. And you have to connect it as a shunt machine. So, these two can be shorted. Okay. Now, this I will parallel it here. Now, in this starter I will connect it like this. This A I will connect it to one of the armature terminals. This F means field terminal, it should be connected here. And this cell will go to supply line, and this of course is to be connected to negative supply. Like that it is to be connected, L, F, A, understood. Then what happens is this, in this starter here physically it will be like this. It is a black box only, but here you will find there will be an handle provided, where it will be written off, where it will be written on sometimes here. So, what the operator has to do is this, he has to, when it is off, it is disconnected, he will move this point gradually like this and ultimately come to this point. There will be several starts here, it will come to on, and he releases his hand, removes his hand, machine will continue to run. And if supply goes off, he has to do nothing. What will be automatically achieved is this handle, it will come back to this position immediately when supply goes off. That is the protective feature it takes into account. Now, the big question is what is there inside this box? It is like this, very interesting, no doubt. And suppose this is your armature, okay, and this is your field winding, and these two, as I told you, and there may be a field resistance connected, then this is RF external, this is your F1, this is your F2, and this is A1, this is A2, and here are the supply terminals will be here, suppose plus minus. Now, what is done is this, there are several resistances. Like this, and from the junctions of these resistances there are some copper strips comes out. These are copper strips, thick copper strips. These bullets are copper strips. So, several resistances are there and it comes like that. And from this whatever comes out is your that terminal A from the starter. From the starter 3 terminal will come out, A, F and L, as I indicated earlier. So, it is this A coming from the starter. I am drawing that box inside what is there. So, this is the armature thing. Acha. Now, what is done is this. There is a handle here. Which is insulated from all the electrical connection, because some operator has to move it, as I indicated. Now, what is done is this part is very interesting. Here there is a small electromagnet. Purpose of this will be very clear like this. Okay. Now, this supply is here, suppose plus, okay. And from this I will draw this with blue wire, this wire, and this is marked as L of this starter. It goes to supply, I told you, and this electromagnet, a small electromagnet is present there, it will go there and very little turn, it comes like this. And then this wire is this electrical wire is taken through this handle inside. Got the point? Black one is you will touch externally. So this electrical wire is taken here, and it will be terminated on a copper strip. So, bullets are all copper strips, thick copper strips. Acha. This is the thing, you bring it here. Acha, there will be another copper strip slightly below it, and you have a thick copper strip here. This is also copper strip, continuous in the form of an arc. You can easily see when I put the handle, the handle may be moved like this way. If you move it this way, it can be moved. If you move it, this point will touch this, and this point will make this strip live, and this position is the off position of the starter. It will make it live, it will make it live. Now, this from this copper strip, comes out your field terminals. Acha. In fact, there is another electromagnet here, which is I will be showing it like this. Okay. So it will be, it is inside this starter, and this wire comes out like this, it comes out, and this terminal is your F terminal here. So, what are the three terminals? ALF, A is here, L is here, and F is here. Now, so field coil is to be connected there in the field, that is what I told. F1 is to be connected to F, A1 to A, and this goes to supply. Okay. So this is your F, and this A1 is to be connected to A, and these 2 points, of course, you have to connect to the negative supply, negative of supply voltage. This is the arrangement. Acha. Now, the interesting part is this one. So, this is the handle, blue one is the wire. Since these are electromagnets, it does something, what for we have connected. There is small iron connected below it. So, that when sufficient current flows, it will be pulled up. It cannot remain in just like that. Whenever there is an electromagnet, there will be spring. So, that when no current, it occupies a particular position, pulls down. Similarly, here this electromagnet, there is a piece of soft iron attached to this, soft iron piece. This is also soft iron. Therefore, when this becomes electromagnet, it will be pulled up. Okay? It is like this. Now, let us see how the things will forget about this electromagnet first. I will tell you, but now suppose these are the position of the stud 1, 2, 3, 4, 5, 6. What the operator will do? He will start moving this one from left to right. The moment he comes here, your armature gets supply with this external resistance connected in series with the armature. Similarly, your field also will get supply. This is live. So, both IA and IF is present. So, electromagnetic torque will be developed, machine will start running. Now, the operator what he will do? He has to cut out the resistance. He will move from stud number 1 to stud number 2, then to 3 as machine picks up speed, then to 4, 5, 6, finally it is here. And when it will be here, this soft iron piece will get engaged with this. Therefore, this electromagnet will attract this fellow, and obviously, there will be a spring here. So, the force of this electromagnet and the spring force, this spring will be stretched, they will keep it in that position. It cannot be without any spring, these are spring, no inductor, spring. Understood? So, it goes there, it will get engaged, your motor will run there. So, in position 6 it is on position, gradually you go, all external resistance now disconnected, only RA will limit the current, and machine has gained enough speed. So, that you do not worry about the starting current. Now, the value some of these resistances then can be selected from, as I told you, the rated current I would like to pass through the armature at the time of starting and things like that. So, when the motor will be running, this handle will be in this position and this soft iron piece is here like that, and everything is fine. Now, the purpose of this electromagnet will be immediately clear. Suppose the supply goes off, this becomes 0. If the supply goes off, this field current will also vanish, and if this field current vanishes, spring will bring back this handle from this position to this position immediately, I mean no time lag. That is why this coil is often called NVRC. NVRC means no volt release coil, no volt, no supply voltage, no volt release coil. It will release the handle to come back to off position. Therefore, there is nothing left for chances that once again it must come back to off position, that is what I want. Because then when supply once again comes in, there is a, for few seconds supply goes off, then it will come back by that time. So, one knows pretty well one has to go through the same process to start this. So, this is called NVRC. Now, what is this fellow doing? This electromagnet, what is the purpose? This electromagnet is like this, its name is OLRC. OLRC, called the overload release coil, overload release coil. What is the, every starter for any motor, induction motor or DC motor, apart from limiting the starting current, it will have some protective features. For example, one protective feature in case of DC motor is obviously must be there, supply may go off anytime, you do not know. So, NVRC takes care of that, it protects the motor from restarting with full voltage. Okay. Overload release coil, it is also an electromagnet, and this you know is essentially the sum of the armature and the field current, this current. In a shunt motor, this current is what? Line current. Line current is what? It is equal to I A plus this is continuous copper strip, this is continuous copper strip. Field current in any case much smaller than armature current. So, this is a measure of armature current. Armature current is decided by whom? By the load present on the shaft of the motor. Suppose there is an overloading takes place in the motor, then also you would like to stop the machine, is not? You would like to stop the machine. So, what you will be doing is this, but you want to stop the machine with the help of the starter, how it can come to a stop? It can come to a stop provided the handle is released from this fellow, it will come to off position, that is what you need to do. How this can be done? It is done so nicely. What is done with this armature? You imagine there is a handle, extended handle, and there is a copper strip here. It is attached to this, a thick copper strip. A thick copper strip is attached to this handle. What all you have to do is this, to bring back the handle from the on to the off position quickly, somehow you have to de-energize this coil. If you make this current in this NVRC 0, you are rest assured this spring will bring back this handle to the off position, that is what I want. So, what is done is this, a little bit of wiring is done. You from this edge and from the two terminals of this NVRC, you bring these two terminals here, so that it is not touching these two when normal condition prevails. Up to rated current, the force is not sufficient to overcome the spring tension to pull it up. So, these two are open circuited, normally open condition, and therefore, everything is fine, it was working. Now, suppose this current exceeds to a large value because of overloading or whatever reason, then what will happen? This force of this electromagnet will pull up this soft iron piece up, and it will go up and will touch these two terminals. So, how can you make current through a particular coil 0? Two ways you can do. You remove the current from the coil, or you put a short circuit across the coil, then all the currents will be bypassed. This is precisely what is done here. Everything is working fine, started the motor on position, then overload takes place. What do I mean by overload? When this armature current becomes pretty large above the rated current. In that case, this current will be also high, and it is so designed, this gap, it will be pulled up. Before that, spring was preventing that. It will go up, this copper strip will go up, it will short circuit these 2 points. Therefore, this field current will now has to flow like this, but the moment it does so, this current becomes 0, and if this current becomes 0, it cannot keep this handle in the on position. Spring will bring back this handle to off position. So, you see this is a very popular starter. It was used considerably, I mean earlier days, or even in some old establishments you will find this sort of starter is connected, and it gives you two protections. One is no volt protection, supply may go off anytime, you do not know, so that no one can start the motor without connecting this external resistance. This is RA external, RA external. It will be released, that is why it is called overload release, no volt release coil. It is in series with the field current. There are improved version on this, there is a 4-point starter, we will not discuss that, I mean no point. In fact, what happens is this this I will mention at later stage. At least one starter you have got some idea, because this is very interesting to know how electromechanical systems can be used so efficiently. It is a very robust starter, do not worry about that. And so, 3-point starter it is, 3-point starter for shunt motor. So, I conclude today, and we will continue with then speed control of DC motors from our next lectures. Thank you.